In this video, I just want to begin by talking about a couple of basic definitions and some ideas about sampling. And in the next videos, we're going to get into to sampling distributions. But to begin with, a couple of definitions. A statistic is data that we took from a sample, and a parameter is data that was taken from a population. Okay, so most times, of course, most things we read about are statistics because we haven't taken the time to sample everyone. So some examples are, sample means, which we write as X bar, or sample proportion, which we typically write as P hat, or a sample deviation, which we typically write as S. Now, these things we are trying to use, these statistics we gather from our samples, we're trying to use to estimate parameters like, I'm going to draw a line here, the sample mean mu, or the population proportion P, or the standard deviation sigma. Okay, so again, you just read carefully and decide is something a statistic or parameter. Bias is when our statistic does not accurately estimate our parameter. Typically, we always say that something is an unbiased estimator, meaning we took a sample, but because we believe we collected a good sample and collected our data in a good way, we believe our sample mean is indicative of the population mean, or the sample proportion is indicative of the population proportion. Bias is when that's not true. Okay, so this is probably one of the most common pictures in textbooks, and I scanned it in here. If something is, imagine that the bullseye is the actual population mean or parameter or whatever. Bias means our sample didn't get close to it. So this is something that's highly biased. We hit the target, but not anywhere near the bullseye. But all the points were clustered together, so we say it's low variability. Whereas here, if you looked at this scattering of points, you'd say, well, they're centered right in here. So there's not a lot of bias there, but the points are spread out. So we say it's highly variable. Of course, this is probably, everything's kind of bad. Actually, I would make a case that this is the worst because when you get a data set that's all clustered together, you think that you really do have an idea of where everyone is, and if it's biased, that's not good. But here, of course, it's both. It's biased, so it's not centered near the bullseye, and it also is spread out. This, of course, is what we hope for, low bias and low variability. All the points are clustered on where they're supposed to be clustered. Let's look at this in one other visual way. Imagine that P is the population proportion. So you can think about the multitude of things you can read about in the newspaper or see on the news all the time. Something has a 50% approval rating, or this new bill, 80% of Americans support it. Imagine that P is the true population proportion or percentage that really supports something. If we took a sample that was highly biased but low variability, we would expect it to be something like this. It's biased, meaning our P hat, our sample proportion, is not close to the actual proportion, but our data sets are all close together. Okay, our proportions. Low bias, high variability means it would be centered around the P, but it would be all spread out. Okay. So in the end, our sample proportion would probably be centered very close to the population proportion, but we've got a lot of spread. Low bias, low variability, of course, this is what we hope for. We hope that we get like bar graphs that are all centered around, the actual proportion. And highly biased, highly variable, of course, means it's spread out, and the P hat would be somewhere up here. So again, bias just means our population, the number we took, our sample, the number we took from our sample, our statistic, is not actually indicative of the population's amount. A statistic that I just recently read and we talked about in my class had to do with the average cost of a wedding. The website theknot.com estimates the average cost of a wedding as $10,000 higher than the actual cost of a wedding. So we would say that that's a biased estimator. And the reason for that is The Knot is a website that couples can start to put up pictures, to make plans about their wedding, to put up their registry. But for all the people that elope or just get married in a very small ceremony, or maybe just go to the courthouse and have a judge marry them, they typically don't log in and create a website and give their information to The Knot, so they're not included. So that is a biased sample.